Hello students, today we are going to discuss some question from organic part and for the class 12. So for class 12 the first organic part is the haloalkane and the haloarene. So today we are going to discuss some question from haloalkane and the haloarene. In organic for organic part the most of the student find difficulties for the organic conversion. So organic conversion is one of the most important part for the organic chapters. So here we are going to discuss some conversion from NCERT exercise. So these are the some question from 10.19 NCERT exercise. So here question number is 10.19. Chapter is haloalkane and the haloarene. That is organic. Organic part for the class 12. So first conversion is the propene to propan-1-ol. So how we can convert propene to propan-1-ol? So if we write the structure of the propene, this is the structure of the propene and this is the structure of the propan-1-ol. So in propene, here the double bond is present and in propan-1-ol, the functional group is OH group. That is here we have to convert the double bond to a alcoholic group. So our target is to convert a double bond to a alcoholic group. So how a alcoholic group can be formed from a double bonded compound. So if we have to convert a double bond to a alcoholic group, then our how we can convert. So first this double bond have to be converted to a haloalkane. That is, first we have to introduce a halide, and the halide group can be converted to any functional group. So if we have to get a functional group, the simplest technique is that first we have to get a halogen. So this halogen can be converted to any functional group. From halogen we can get a alcoholic group. From halogen this halogen can be converted to a carboxylic group. From halogen aldehyde group can be obtained. From halogen an amide group can be obtained. So we can get any functional group from a halogen, that is from a halide. So here we have to get a alcoholic group, that is OH group. So from the double bond, how we can get a OH group? The first aim is that we have to get a halide group. So in which carbon we have to get a halide group? This OH group present in the first carbon atom, that is a halogen group have to be introduced in the first carbon atom. So from this compound first we have to get a halogen in the first carbon atom. So a double bond, from the double bond if we use HBr, then addition of HBr to a alkene takes place according to the Markovnikov's rule. So a negative part is Br minus, positive part is H plus. So if we use the Markovnikov's rule, the negative part goes to that double bonded carbon which carries the less number of hydrogen. So these two carbon is the double bonded carbon. One double bonded carbon carries one hydrogen, other carries two hydrogen. So the middle carbon is that carbon which carries the less number of hydrogen. So if we use HBr, then the Br minus will goes to the second carbon atom. But here our alcoholic group is present in the first carbon atom. That means addition of HBr to this alkyl will not give this alcohol, because in this alcohol the OH group present in the first carbon atom, and addition of HBr, the Br minus will goes to the second carbon atom. So addition of HBr to this alkene does not give the product. Now here Br minus will have to go to the first carbon atom. So if Br minus goes in the first carbon atom, then we have to use the peroxide. So addition of HBr in presence of peroxide will take place according to anti-Markovnikov's rule. The anti-Markovnikov's rule is that Br minus goes to the carbon which carries the more number of hydrogen. that is Br minus will goes to the first carbon atom and H plus will go in the second carbon atom. So here we will get the CH3, then CH, and this from HBr the hydrogen will goes to the second carbon atom, so it will be CH2, next CH2, then the Br. So Br will goes in the Br minus, that is bromide, goes in the first carbon atom. So here in the first carbon atom we are getting a halogen, and in our target the first carbon atom will have to bonded with a OH group. That means here the Br minus, that is the bromide group, have to be substituted with the OH group. So from this alkyl halide, if alkyl halide is treated with aqueous NaOH or aqueous KOH, that is NaBr is removed, then the OH group will be substituted in the first carbon atom and we will get this product. So by this method we can convert the propene to propanol. But this is not the only method for the conversion. A conversion can be carried out by a more than one process. So this is one of the process that by which we can convert a propene to propanol. So what we have done first, in this propene, first we are trying to introduce a halide group. So by addition of HBr in presence of peroxide, addition takes place according to the Markovnikov's rule, and the negative part will goes in the first carbon atom, that is Br minus goes in the first carbon atom. That means we are getting this product. Now from this product, if we is treated with aqueous NaOH, then NaBr is removed. This reaction is the nucleophilic substitution reaction, and the OH minus will substituted by the bromide, then we are getting this alcohol. Next method, that is next question is ethanol to butane. So ethanol CH3 CH2OH, this is the butane. This is the second. In ethanol there are 2 carbon atom, in the butane 4 carbon atom. So 2 carbon to 4 carbon, that is their carbon chain is increases. So how we can convert? So one of the best process for the organic conversion is that first introduce halide, that is first introduce halogen. Halogen can be converted to the any functional group. So here also first we have converted this alkene to a halide, then this halide is converted to halogen, that is alcohol. Here also this halide, this alcohol is converted to a halide, that is haloalkane. So alcohol when treated with SOCl2 in presence of pyridine, then the product is alcohol when treated with thionyl chloride in presence of pyridine. What is the product? Product is haloalkane CH3 CH2Cl. Now from this compound how we can get the butane. Now if this haloalkane, if it is treated with, if this haloalkane is treated with C triple bond CH and C minus Na plus, when this alkyl halide is treated with this compound, now here NaCl is removed. Here the C minus will attack with this carbon and Cl minus is removed. Now this CH2, this carbon will now get bonded with the triple bonded CH. So CH3CH2. Now this CH2 will get bonded with the triple bonded carbon. So CH2 will get bonded to the triple bonded carbon, and this C triple bond again CH, so C triple bond CH. So this is one of the process by which we can convert the ethanol to butane. This is not the only method, that is only process for the conversion. So a conversion can be carried out by more than one process. So this is one of the process by which we can convert ethanol to butane. Next conversion is 1 bromopropane to 2 bromopropane. So here carbon chain is same. In 1 bromopropane there are 3 carbon atom. In 2 bromopropane also there are 3 carbon atom. So carbon chain length remains same. Only the difference is in the position of the halide. So in 1 bromopropane the halogen is present in the first carbon atom. In 2 bromopropane the halogen is present in the second carbon atom. So carbon chain length remains same. Only the difference in the position of the halogen. So if the difference is in the position of the halogen, then the conversion can be carried out via the formation of double bond. When there is only difference in the position of the substituent, then this process can be carried out via the formation of double bond. So how we can how a double bond can be obtained from this compound, that is how a alkene can be obtained. Double bond means alkene. So from alkyl halide, how a alkene can be obtained? So alkene is obtained via elimination reaction. From alkyl halide, alkene can be obtained by elimination reaction. So in elimination reaction, reagent is alcoholic KOH, alcoholic potassium hydroxide. So if we use alcoholic KOH, then from this carbon one halogen is removed, and from the next carbon atom one hydrogen. So from this is alpha position, this is beta position. So from these two carbon atom, from one carbon atom halogen, and from the next carbon atom hydrogen, so H and Br, HBr will be eliminated and a double bond will be formed. So if this from one carbon atom halogen, from this carbon atom halogen will be removed, from the next carbon atom hydrogen will be removed, and the single bond will be converted to double bond. So we will get the CH3 C double bond, that is CH double bond CH2. So halogen is removed, from the next carbon atom hydrogen will be removed, the single bond is converted to double bonds, we are getting this product, that is alkene is obtained. Now from this alkene, how we will get a alkyl halide? From alkene, if we use HBr, that is addition according to Markovnikov's rule. So in HBr, negative part is Br minus, positive part is H plus. So according to Markovnikov's rule, negative part will goes to the carbon, which carries the less number of hydrogen. These two are the double bonded carbon, so this carbon carries the less number of hydrogen. So negative part will goes to this carbon atom, positive part will goes to the first carbon atom. Then we are getting this product, that is 2 bromopropane. So 1 bromopropane to 2 bromopropane can be carried out via the formation of double bond. So alkyl halide is converted to alkene. This is the elimination reaction. In elimination reaction, reagent is alcoholic